This demo will show Inmanta Connect. Inmanta Connect is a connectivity-oriented solution on top of the Inmanta service orchestration platform that allows you to orchestrate connectivity services. These services include Carrier Ethernet, IP VPN, bandwidth on demand, cloud interconnect, and so on. For the demo today, we will be using the following lab setup. The lab setup consists of two routers connected to each other, and each router has two subscribers attached to them. They are connected over an IP MPLS network, and both routers are Nokia routers. These routers will be orchestrated with the Inmanta service orchestrator, and the topology is documented in an inventory system with which the orchestrator integrates. For this demo, we are using Netbox. It's a freely available inventory system. We can integrate with other inventory systems that you already have to fulfill this service. This brings us to the Inmanta dashboard. Here we will go to the service catalog, and inside the service catalog we have one service called Carrier Ethernet EVC. For this service we use the MEF layer 2 Carrier Ethernet EVC model. This data model is MEF compliant, but it does add some complexity. If you want another API, you can adapt this model yourself. So we're going to add one instance. You can choose the connection type, multi-point or point-to-point. In this case, we're going to use a point-to-point service. We give it an identifier, and then we need to add the two endpoints. Each endpoint has its own identifier as well. The form that you see here is quite complex. The reason for that is that we generate a REST API based on the orchestration model. This REST API gets an automatic form in our front end, and that's the form that you see here. Typically, you will not use this directly, but use the APIs to integrate this within your OSS BSS. And then we specify the VLAN on which the service needs to be exposed. Then we need to reference a UNI on which the subscriber is connected. The reference here is a reference to an item in the inventory system. So let's go to Netbox. And in Netbox, we have the two routers from the topology modeled. It's the eBest and the East router. You see them here, and each of these routers have interfaces. And some of these interfaces also have a UNI identifier. In this overview, we can see them. Each router has two interfaces to which subscribers are connected, and they have a UNI identifier. We're going to use this interface on the East router. And then we'll populate the form for the second endpoint. And here we will also expose the service on the VLAN. Here we again reference a UNI in the Netbox inventory. And now we're going to use an interface on the West router. We support multiple inventory systems. So that means that if you have multiple inventory systems, or you want to use the built-in inventory first and then later migrate to your inventory system, we can support multiple types of inventory references. We also support multiple networking backends. In this case, we're going to deploy the service using EVPN instead of LTP signaling. We add the high-level intent to the orchestration model. Our orchestrator is an intent-based orchestrator, so you do not tell the orchestrator which steps it needs to take to fulfill this service. You will just tell the orchestrator what you want to have available in the network, and the orchestrator figures out the workflow to get there. If at the moment you submit this high-level intent, we will add it to the model. We validate the intent. And if it is valid, we start refining this and breaking this down into low-level intent that we can deploy into the network. In this case, we have split this out into netconf resources that will go on each of the routers. And specifically, we have resources on the east router and the west router. There is one specific for this service that we created. So we deploy a Nokia ePipe with policers in place to make sure that we constrain the bandwidth as specified in the request. And we can also manage some of the global configuration which is required for any of the E-line services that we deploy here, or the Carrier Ethernet service. So for example, the global resource here. And in this case, this is making sure that EVPN is enabled and that the ETH CFM configuration is correct. The service now has been deployed. If you want to use this solution in something like bandwidth on demand, you can easily send patch requests to our API to change the bandwidth, or you change the bandwidth using our front end, and that's what I'm going to do now. Let's first show the service in our in the devices themselves in the network. So this is one of the sides of the VPN. It's up, and then if we dig a bit deeper into the configuration, then we see here that the information rate is set to 10,000, and this is the value that we entered in front end of the orchestrator. We update this, for example, we want to go to 100,000. And we're going to do this on each side of the line. And again, we're going to validate this intent. And if this intent is correct, we will push this into the network. So we're now running the validation. And in a moment, the update will start. So the update has been deployed. In case this would failed, we could roll back to the previous intent. And that's what this icon indicates. So if you look closely at all of the attributes this service has, is that we see here that the previous version is 10,000, but now it's 100,000. What you can see here as well is that we fetched quite some data from the inventory and added this to the service to be able to fully deploy the service in the network. But we're not only managing the network itself, we're also documenting the service in the inventory. So if we now go into the inventory and, for example, select this interface, we will see here that there is a child interface attached on the VLAN that we specified, and this child interface is part of a layer 2 VPN with the name EVC1 and the circuit ID 10,000. If we then go into the layer 2 VPNs, we will see it listed here with these two interfaces in there. Our orchestrator is intent-based, so that means that it can also detect changes in the network and fix them again. That's what I'm going to demonstrate now. So we have the ePipe service on this router with its full configuration. And now if somebody would update the MTU to another value, the service will actually go down. It's down because there is an MTU mismatch. The orchestrator can integrate with assurance systems, where the assurance system notifies the orchestrator and we will immediately try to repair it. Alternatively, we check every X time whether the desired state still matches the current state. We can also force this using this repair button. And when I click repair here, then in a moment, you see here that we're rechecking all of the resources. And when this is done and we go back to the network, we will see that the service is back up. So the service has already been restored. Because we are intent-based, that also means that we know what should be there and what should not be there in the network. And that means that we can easily also clean up the network and the inventory. So when I click delete here, we will again assert that the intent will say that the service should not be there. We go to the network, we see that the service is still there, and we delete the service. So here the service is gone. And if we go to the inventory, the service here is also deleted. That concludes the demo of Inmanta Connect.